So we are going to review simplifying radicals because we are going to need that on when we work with the Pythagorean theorem, but then also we are going to be doing operations with radicals as well. So remember, when we simplify radicals, we are looking for perfect squares inside of the radicals, okay? So how we do this inside radicals is we are going to break down 150 into factors that multiply to become 150. So if I were to think about this, I can break this down into 25 and 6. So if I were to do 25 times 6, that would bring me back, to 150. Why I wanted to use 25 is because that is a perfect square. So remember, with radicals, if it's a perfect square, we can take it out because there's a pair that can get taken out. 6 just breaks down to 3 and 2, so we can't take either one of those out. So how we would write this as the simplified radical is this 5 comes out on the outside and 6 stays on the inside. So if you want to pause the video and see if you can do these examples, remember when there's a number outside the radical, we're going to multiply. So if you want to pause this just to refresh and then double check your answers. So then 8 breaks down into 4 and 2. And then we can take out this pair of 2's from the 4. And then this 2, since it doesn't have a pair, stays inside the radical. So it would be 2 square root 2. 200 can break into 102. 100 breaks into 10 and 10. So here's our pair. So when we do this, it becomes 4 times 10 square root 2. So 4 times 10 is 40. So it's 40 square root 2. And then this last one here, 175, we can break that into 25 and 7. This breaks into 5 and 5. So again, this becomes negative 2 times 5 square root 7, so negative 10 square root 7. So that was the quick refresher on how to simplify radicals. So to add or subtract radicals, they need to have the same number inside the radical and you add or subtract the outside numbers. All right, so if we look at this first one here, they both have the square root 11 inside the radical, so that means we can combine these. So when I do that, I just add the outside numbers, or subtract them in this case. So we're going to do negative 10 and combine it with negative 11, so that'd be negative 21, and then we just leave the radical, square root 11. So that is how we would combine those, negative 21 square root 11. Now if you look here at this example, 27 and 3 don't match. I can't break down 3 since it only breaks down into 1 and 3, but I'm going to see if I can break down 27 to simplify it and see if we can combine it. So 27 breaks down into 9 and 3. I can take out this pair of 3's. So this 3 square root 27 becomes 3 times 3 square root 3. Look at all those 3's. So it's 9 square root 3. So now we have negative 2 square root 3 plus this 9 square root 3. So again, now I can see that the radicals match. So then I just combine the outside numbers. So negative 2 plus 9 is 7. And so the final answer would be 7 square root 3. So if you want to pause and try these two examples, that would be a great idea. Okay, so if I look at this first one, 2 square root 6, 6 only breaks down into 2 and 3, so I can't simplify that one. 24 breaks down into 4 and 6, so we know we can take out these 2's, so this becomes negative 2 times 2 square root 6, so negative 4 square root 6. So now we have 2 square root 6 minus 4 square root 6. So since the radicals match, we combine the outside numbers, and negative 4 and 2 together is negative 2. So negative 2 square root 6. And then finally, our last one. Again, we know if it's a radical 6, we can't break it down. 54 breaks down into 9 and 6. I can take out this pair of 3's. So we do 3 times 3 square root 6. So 9 square root 6. Oops, cut it off there. So 2 square root 6 plus 9 square root 6. Combine the 2 and the 9. So 11 square root 6. So that is how we can do operations with radicals.